So the dilemma comes in recognizing whether a polynomial is a perfect square or not, right? That's what you have to be aware of. So remember what a perfect square is. All that is a plus b squared. So if we know which one's a and which one's b, holy smokes, we're in the money. Take a look at this. Remember what this means. This means a plus b all squared. And look at the pattern. Always look for the pattern. You have an a and an a, which gives you an a squared. You have a b and a b, which gives you a b squared. And then there's an AB and an AB. So in fact, you're going to look at a squared plus 2ABs plus b squared. But wait a second. How does this relate to this? Well, simple. That must mean that this first term has got to be your a squared term. And look, lo and behold, it is. If you look at this as your first term as your a squared terms. So that's 121x squared. And all you have to do is square root this. When you square root this, you're going to get 11x. There's your first term. Okay, now look at this. This must mean that this is your b squared right here. So your b squared has to equal to 36. Square root it, b equals to 6. So what do you do now? Look at this middle term. You have an a times b. See? It's an a times b, an a times b. And you're doubling it. Aha! So we're going to take our a term here, multiplied by our b term to give us 66x. And then all we're going to do now is double it to give you 132 x's. Aha! And lo and behold, look at that. Now, there is a bit of an interesting dilemma here. The dilemma is it's minus, and we are always dealing with pluses. Well, so what? Look, if this is a minus and that is a minus, you still get an a squared and a b squared. Why? Negative times a negative is always a positive, right? But in the center here, you're going to get a minus ab and a minus ab, making this minus. So that must mean this original term here should have been a negative. Watch. You're going to get, in fact, a factor here of, there's your a, 11x, there's your b, which is 6, and because of that, that's what's going to determine everything. That's going to be a negative, and the whole thing is squared. There's your perfect squared polynomial, nicely factored. So with that in mind, we took our time on this one. Let's see if we can cruise through the next one and see if this one is in fact a perfect square or not. So at this point in the podcast, you might want to just pause the podcast, try this question yourself, and see if you can figure it out. If not, watch this and I'll show you how to do it. Here we go. Ready? Take this first one. You must know that that's got to be your a squared term. And that is, sorry for the tongue tie there, that's got to be your 9v squared. Then square root it. That's going to be your 3v. Okay, take a look at this one. So what if it's got a w on it? I don't care. That's your b squared, which is 64w squared. Square root it. This must mean that this is 8w. Now, remember what you had to do first. You have to multiply those together. 3v times 8w gives you 24vw. And don't forget that that has to be, times 2 to give you 48 VWs. And look at what you have here. And again, there's that telltale negative sign that tells you that this is going to be 3V, 8W, and because this is a negative, this is a negative, and then just square it. There's your factorization, and boy, that's awesome. So the cool thing about this is being able to recognize that these are, in fact, perfect squares. And if you're ever stuck, always go back to this idea of a plus b, right? And recognize that this is an a squared, that's a b squared, and you've got your two ab's in the middle. That'll help you out every single time.